Okay, good evening folks. Today let's start our second day of Hadoop session. Now today I'll start with difference between Hadoop and SQL. Okay, so when I say SQL, I'm talking about RDBMS. Now till today we were saving a lot of data in RDBMS. Let's take an example of Oracle or MySQL and all. Okay, and Hadoop can also deal with a huge amount of data. So the question is, what is the difference between this SQL and Hadoop, and why should we actually go with Hadoop? Okay, now the first basic difference is Hadoop believes in horizontal scaling, whereas SQL believes in vertical scaling. Please ignore my typos. I may write sometime wrong spelling because of the fastness. So we already discussed what is horizontal scaling and what is vertical scaling yesterday, is not it? So ideally Hadoop is basically for horizontal scaling. That means in Hadoop, if you get sort of memory, if you get sort of processing power, if you get sort of RAM, then just go and add one more computer and it will be able to process your data. But in case of SQL server, in case of your SQL database server, if you feel that the SQL database is not enough, not capable of storing more and more data, then you need to go with vertical scaling, which means add more power to it. And there is a drawback with this vertical scaling. The problem is the limitation with the hardware. Okay, we cannot go and say we cannot install 1 terabyte of RAM in a system. That's not it. But we can definitely, in case of horizontal scaling, we can definitely use many systems which are of 8 GB each, 8 GB RAM. Okay, so altogether it may become 1 terabyte of RAM. Next, in case of SQL, we have SQL queries, right, to process the data. For example, let's say select employee name from employee, where employee designation equal to manager. So in case of your SQL queries, we generally deal with in case of your SQL or RDBMS, we generally deal with SQL queries, something like this. But in case of your Hadoop, we will deal with MapReduce program. Okay, that means we are not going to write SQL queries to do some processing on our data set. We are going to use something called MapReduce program. We will see that in detail in the coming classes. So this is the basic block of Hadoop. In case of Hadoop, we will write MapReduce program, and the MapReduce program will be executed on your data, and it will give you result out of it. Third, SQL is designed to store the data in tabular format, that is structured data. Okay, Hadoop stores data in key value pair format. In case of SQL, we generally deal with data, and that data is stored internally in terms of tables, rows and columns. But in case of Hadoop, the data will be stored in a key value pair. Okay, for example, you say employee name, employee age, employee salary. 101, employee is 25, salary 3000. 102, 27, 5000. Okay, so we use this concept in SQL, whereas in case of Hadoop, we may present the data in this way: name equal to 101, employee age equal to 25, employee salary is equal to 3000, employee name is equal to 102, employee age is equal to 27, employee salary is equal to 5000. Okay, so this is not the exact way of representing the data in terms of MapReduce programming, but I'm just trying to give you an example that in case of MapReduce, generally we deal with key value pair. We will get to know how do we use key value and what is the exact format, but for the timing, just get yourself convinced that in case of Hadoop, in case of MapReduce programming, the input data, everything will be in terms of key and value. Fourth, SQL is for real-time processing of data. Okay, your Hadoop is designed for batch processing. Now, can you guys tell me what is the meaning of this real-time processing and what is batch processing? Okay, now your real-time processing is nothing but the process in which the data, the results should be returned immediately, very immediately. For example, when I do any sort of online transaction, okay, in the payment page, when I try to pay that through my credit card, automatically one-time password is sent to my mobile number, registered mobile number, is not it? And as soon as my transaction is done, immediately I get one SMS alert saying that your credit card was used to make a transaction of so and so amount. So this is what we call a real-time transaction, real-time processing. That means the query and the output, okay, should be very fast. Whereas when we talk about batch processing, that means I am not looking for result right now immediately. You give me the result after two hours, after 10 hours, after 24 days, it's up to you. Okay, so this SQL is basically meant for real-time processing. When you want to get quick result, use SQL. And Hadoop is for batch processing. When you don't want quick result, use Hadoop. But again, there is a difference because SQL will not be able to process huge amount of data, right? Whereas Hadoop can process huge amount of data. Fifth, in SQL, you can update the record. In Hadoop, you cannot. So let's say I have an employee table which contains employee name, employee age, and employee salary. Okay, and the employee salary is 3000 here, and I would like to update this detail. So I'll simply write on update query, update employee, set employee salary is equal to 4000, where employee name is equal to 101. Okay, but this type of feature is not available with Hadoop because Hadoop is basically for batch processing. Okay, so if you have a file, let's say employee.txt, and if you have stored this file in the Hadoop system, then Hadoop system will not allow you to modify data. Are you getting my point? Now what to do if I really want to modify this data? Very simple. you bring that data from Hadoop to your system. Okay, modify the changes and again put the data into the Hadoop system. Alright, so if I assume this hadoop.txt is of let's say 1 terabyte, the size of, okay, now I was just talking about this. In case of SQL, you can update the record, you can delete, you can do anything inside the record, but in case of Hadoop, you are not allowed to do that. Okay, the reason is very simple. Let's say I have one employee.txt which is of 1 terabyte. Okay, now this file, if you load it into the Hadoop system, if you give it to Hadoop, then it will store the data. Okay, and then you are not allowed to make any changes. The reason is very simple. Hadoop is basically given to process the data in batch. Okay, it is really not given to store your data. Excuse me, guys. Okay, so it is really not given to store huge to perform any insert operations and all. We'll come to that very clearly when we discuss more about Hadoop. Okay, now another difference. Hadoop is free with Apache license. Okay, need commodity hardwares, whereas SQL servers are high-end servers with expensive hardware. Okay, and with this point there is a major difference, like the hard disk whatever we use for Hadoop programming. Okay, it can be a simple non-reliable hardware as well. It can be. Okay, but usually your SQL server uses RAID disk. Okay, there is a full form, redundancy, error and independent disk. There is some meaning on that. Okay, so basically SQL servers, they use this kind of RAID, where what happens, wherever you store data, the data will be replicated and the data will be stored on the hard disk, so that even if it fails, then you will still have some place to take the backup from. So are you convinced with the difference between SQL and Hadoop? And one more thing, as I said, in case of Hadoop, we are going to write MapReduce programming, but Hadoop also provides some sort of components, okay, using which you can write SQL kind of syntax. Okay, see, just now I told you that in case of SQL, in case of RDBMS, we usually write SQL query to query the data, to process the data. True. And I even said that in case of Hadoop, we will write MapReduce programming. It's not it. But to make the life easy, okay, the Apache people, they have also come up with some other sort of component using which you write SQL query, but behind the scene that SQL query will be converted into MapReduce program, and the MapReduce program is the ultimate program which runs behind the scene. Okay, so directly or indirectly it is your MapReduce program only. Now let's start with some basic terminology. Let's start with some basic terminology in Hadoop. So the first is node. Node. Can you tell me what is a node? I will say a node is nothing but an independent computer or processor, okay, with its own RAM and hard disk. Any independent computer or any independent processor which has its own RAM, which has its own hard disk. For example, if you have your laptop connected to 4 hard disk, let's say you have USB ports, and in all 4 USB ports you have connected 4 different hard disk, then you cannot say that you are dealing with 4 or 5 nodes. It is the single node only. But if your computer is connected to another computer, again that computer is also connected to another computer, now you can say you are in a network with 3 nodes. You are in a network with 3 nodes. So node is nothing but any independent computer or processor which has its own processing power, which has its own hard disk. Okay, now this is node. So next is cluster. What is a cluster? A cluster is nothing but a set of node, I will say computers, in a network in such a way that they can interact with each other. So we'll go with a diagram. This is my computer 1, and this is my computer 1, this is my computer 1. So I have 3 computers: computer 1, computer 2, computer 3. Now in terms of Hadoop, we will not call it computer, we will call it node. Node 1, node 2, and node 3. So let's say these computers are interconnected to each other. This is connected to this, and again this is connected to this. This is connected to this. That's all. So let's say these 3 are interconnected to each other. Now you can call it a cluster. And in case of Hadoop, do you need that these 3 computers should be of same configuration? Yes or no? Yeah, ideally no. You may have this computer with very high-end processors, i7, 8 cores, and let's say 16 GB of RAM, and let's say 4 TB of hard disk. Whereas you may have a Pentium 5, let's say 2 GB of RAM and just 200 GB of hard disk. Now you can use any node in which Hadoop can be installed. You can take it as a Hadoop, you can use it in the Hadoop cluster. Alright, so you may not be able to work with the computer which you might have used in your school days, because that will have a limitation. You will not be able, it may not have it may not have great power to install Hadoop on it, so you may not be able to install that, use that as a node. But any system in which you can install Hadoop, any minimum requirement system in which you can install Hadoop, that can be used as a node. So all these 3 together will form a cluster. So we'll also see how to create our own cluster. What we will do is, we will install Hadoop in system 1, we'll install Hadoop in system 2, we'll install Hadoop in system 3. okay, and then we'll connect it all together, and then you will see that whenever I want to process a data, that data will be processed by, some part of data will be processed by this computer, some part of data will be processed by this computer, and some part of data will be processed by this computer, okay, and all together you will get the result in one third of the total time. Next I'll talk about block. Can you tell me what exactly a block is? Anyone? To be more specific, a block is a small unit of data, okay, a small unit of data. So again we need to see this through example. Let's say this is my computer memory, okay, let's say this is my the memory of my computer. Okay, so let's assume that this is the computer, my computer memory, and all these are actually are capable of storing one bit, 0 and 1. Okay, so here 0, 1, 1, 0. Okay, now this is 1 bit, this is 1 bit, this is 1 bit, this is 1 bit. So if I have 8 bits, that will become 1 byte. Okay, so in computer, like in a general computer term, usually we measure the data in terms of byte, is not it? And we may call it as a block. Okay, we may call it as a block. That means a set of memories, a set of connected, a set of consecutive memory where we usually store data. Now in case of Hadoop, the default block will be of 64 MB. The default block will be of 64 MB. That means these are bytes, right? These are bits, 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this is completely 1 byte. Now if you take more, if you take from here to here, okay, it may be, let's say 10 MB. Again, if you take from here to here, if you take from here to here, let's say this goes to 64 MB. So 64 MB is the block size in Hadoop. That means whenever you try to write any data, by default it occupies 64 MB. Okay, it will take 64 MB. It will write the data only whatever you need, and the rest of the block will be actually free. So are you getting my point, what I'm trying to explain? So as per the computer basic rule, we have bits and bytes. Okay, but in case of Hadoop will take the collections of so many memory allocations, and it will construct something called a block, and the size of the Hadoop block is 64 MB. Do you understand my point? Yes or no? So I can say a block is nothing but a small unit of storage in case of big data or in case of Hadoop. Now it will do in hard disk. Actually, it will not do in memory, it will do in hard disk. We'll come across that. Okay, so how does the data where exactly the data gets stored, will come across this, not in the memory, because when you say memory you are referring to RAM. It will be stored on the hard disk only. Okay, otherwise if the system goes down, then you will lose the data, is not it? So the data will be stored on hard disk only. Okay, so let me make it more clear. Let's say I have something called employee.txt, which contains some data, right? And the size of this is let's say 10 KB. Okay, so when you try to store this file on Hadoop system, it will take 64 MB by default. Okay, so what it will do is it will start occupying 64 MB. Let's say the 64 MB goes from here to here. Okay, let's say this total is of 64 MB. So to store this 10 KB size of file, it will occupy 64 MB, and it will start writing the data here, and then whatever memory it is not using, it will free it up. Are you getting my point? Let me make it more clear. Now I have employee1.txt and I have employee2.txt, two files. The size of this is 20 KB. The size of this is 40 KB. Okay, so what is the total size of these two files? 60 KB. What is the default size of our block? 64 MB. Will it not be sufficient to hold this? But still, what it will do is it will occupy two different memory space. Of 64 MB each. Okay, now let's say block 1 total is 64 MB. What is the what is the size that was occupied? 20 KB only. Block 2 64 MB. What was the size occupied? 40 KB. Okay, I mean to say, if you have two files, it will consume two different memory space of 64 MB each. It will occupy whatever is needed, and rest of the memory will be free. Getting my point? So block is nothing but a small unit, a small entity which will be used while storing the data, and the default size of the block is 64. That means even if you have a file of 1 KB, it will still occupy a block of 64 MB, stores the data whatever is needed, and then the remaining memory will be set free. Okay, so the block is nothing but a unit, the minimum unit, okay, which will be used to reserve the memory space in the memory. Now we also discussed block size. Right, so the block size is nothing but the size which will be used to create a block, a default block in Hadoop. Now the default block size is 64 MB. Okay, so if you are working with Apache, okay, so I was just discussing about the block size. So I was just talking about the block size. Now the default block size of Apache Hadoop is 64 MB, but in case of distributions, I'll talk about that. What is distribution? The default block size is 128 MB. Okay, now we all know Apache Hadoop. It is actually a free version. It is actually a free version, but there are some company who have taken this free version and they have customized the version and they started selling it at some nominal cost, and we call them distributions. Okay, so the distributions, the popular distributions are Cloudera, Hortonworks, even Oracle. I believe Intel is also there. Okay, so these are the basically, see, Hadoop is the software given by Apache, and if you are working with Apache, you don't need to pay anything extra. Okay, but there are some companies who have taken this free Apache Hadoop, they have started customizing it as per the business requirement. Okay, they'll give you support also, 24/7 support you'll get. All right, but they will charge you something if you want to use their system. Okay, so here it is basically a normal Apache Hadoop, but these are all customized Hadoop. Yes, Sunit, you are correct. The block size, the default block size in operating systems varies. Like if you can say 4 KB, but in case of Hadoop it is exactly 64 MB. Okay, in case of Apache Hadoop it is 64 MB. In case of distributions it is 128 MB, and again this can be configured. It is up to you. You can configure it. You can configure it as per your requirement. Now let's take one example. Let's say I have one file of 200 MB. Okay, let's say I have one file of 200 MB and I want to process this file in Apache Hadoop. What is the block size of Apache Hadoop? 64 MB. Now how many block will it need to process this 200 MB? How many block will it need to process 200 MB? 64, 3, yeah, 4, exactly 4 blocks. Okay, so when you give this 200 MB of data to Apache Hadoop, okay, what it will do is it will divide your file logically into blocks of 64. Okay, so block 1 will be 64 MB, block 2 will be 64 MB, block 3 will be 64 MB. What remain? 18 192 8 MB. Block 4 will be 8 MB, right? 64 64 64 and 8. Okay, so your file of 200 MB was divided into 4 blocks: block 1, block 2, block 3, block 4, and then this will be processed independently. Alright, now let me talk about the next example, next split. Okay, the next terminology is split. So if I say the let's take the example of a file employee.txt. Okay, here we have some data: 1001 Suraj, Java, let's say team lead. 1003, let's say Kumar, .NET, let's say fresher. 1005, let's say Ravi, Hadoop fresher. Let's say 1008, Kiran, Hadoop manager. Okay, so let's assume that this employee.txt is of 200 MB. Okay, now I'll not take 200 MB, let me take 100 MB. Okay, 100 MB. Now into how many blocks this will be divided? Two blocks. So block 1 will be of 64 MB, block 2 will be of 36 MB. Okay, now let's talk about this data. This is 1 KB, this is 10 KB, this is let's say 60 MB. Okay, and let's assume till here it comes 64 MB, or let me make it like this. Let's say till here it comes 64 MB. Are you getting my point? Let's assume that the data from here to here actually comes to 64 MB. Okay, so as per that, block 1 will store this data, and block 2 will store this data. So don't you think there is some data corruption here? Because when you process this data from your MapReduce program, the data will be processed line by line. Okay, the data will be processed line by line. This line will be processed successfully, this line will be processed successfully, whereas in this line you will get a problem because the data is missing here, and this will also be not processed. Okay, so when we talk about block, the block means complete 64 MB. Okay, but actually in the real time your data may not be stored in 64 MB, but it may be something like 63.7. and what is this 63.7? From here to, let's say, here. Okay, and the remaining part will be stored in another block. So it may be 36.3. Okay, and now it will be stored like this. Getting my point? So this is what we call split. The split is 63, the block is 64 MB, the block size is 64 MB, but the split is the actual data stored, the actual size of the data that is stored. Are you getting my point? Are you getting what is the difference between the block size and the split? Block is basically the smallest unit in which the data will be stored in the system, whereas split is the actual data where this boundary check will also be taken care. Okay, if the total data from here to here comes to 64 MB, then it will not store 64 MB. Okay, it will store only till here. Or else if you say, let's say from here to here it comes to 64 MB, okay, then it will not store these two characters, it will just store a complete record. Always it will store complete record, because when you write your MapReduce program, your MapReduce program will execute per line. Okay, for each line the program will be executed. We will see that for each line the program will be executed, and Hadoop makes sure that whenever you store your data into the Hadoop system and whenever your file is divided into blocks, it will take care of the boundary check in such a way that the lines are not broken and the data are not corrupted. Will the data splitted before storing blocks by MapReduce? We have really not started MapReduce, right? And we did not discuss something called SDFS. So this data will be broken down before it is stored in the SDFS. So I'll talk about that in great detail. Okay, so for the time being, just try to understand that whenever the data is stored in Hadoop system, okay, whenever the data is stored in the Hadoop system and whenever it is given for processing, you will never get a problem of the data inconsistency. You will not get the problem of data getting tampered. Okay, how? That is a like that we will discuss in the coming classes. Okay, now let me start the main point.